All right, on today's episode of Python Poppy, we're back inside our TensorFlow course, and we're still doing our malaria diagnosis data preparation module. Let's have a look at what we went over today. Yesterday, if you recall, we went over the process of changing our ratios, our validation ratio, our train ratio, and test ratio to see more examples of how we can use these. We're going to pick up where we left off. So yesterday we had a 0.8, 0.1, and 0.1. Today we're going to use 0.6, 0.2, and 0.2. So that's going to be 60%, 20%, and 20%, which is still going to give us 100%. And we're still using a range of 10. So notice that we'll return the first 60 elements in our list of range of 10. You can see that's here. That's what this algorithm here is doing for us. It's actually going to return to us 60% of our range of 10, which is going to return here 0, 1, 2, 3, 4, 5, which are the first 6 elements in our range of 10. So that's what that's doing for us here. Also notice that we left out the other 40% of elements remaining. So notice that we're missing 6, 7, 8, and 9 out of our range of 10 because we specified we only want to take the first 6. So we got back to 0 through 5, but we left out the 6 through 9 because we didn't use the last 40% of our data. Note, we did not change the length of the data set, only the percentages on which we train, validate, and test on. Now let's see how we can get this other 4 elements, or the last 40%. To obtain those last 4 elements, we will use these steps. So we're going to define our validation. And instead of taking the first 6 elements, we're going to skip the first 6 elements. This way we can get the last 4 elements that we want. This is the algorithm, or this is the equation we're going to use here. Val dataset equals dataset.skip. This time we're telling it that we want to skip the integer of the train ratio because we know the training ratio is 0.6 or 60%. So we're going to skip that, and we're going to get a return of 6, 7, 8, and 9. Let me actually go ahead and compile this because it's not going to take long at all. And I can actually show you what it looks like while it's running. So yeah, so after we skip the first 6, we're going to get back the last 40% or the last 4 elements that we were trying to target, which is 6, 7, 8, and 9. Notice that with this method, we are returning the last 4 elements inside of our list of range of 10. But recall that val ratio is used on the elements, or the 2 elements 6, 7, that's specified by the val ratio equals 0.2. So what that means is 6, 7 is going to represent our validation ratio, which is 0.2 or 20% of the last 40%. So you can see 6, 7 would be our validation ratio. So what we're going to do again is, after skipping and getting the last 4 elements, which essentially is made up of the validation ratio and the testing ratio, because the testing ratio makes up the other 20% of the 40%, which is 8 and 9, the 2 elements 8 and 9 inside of the range of 10, or the last 4 elements in the range of 10. We are now going to take out the first 2 elements of the remaining 4 elements, which correspond to the val ratio set 6, 7. To do that, we'll use this method in the code we just wrote. Val dataset equals val dataset.take. Notice that we are making our val dataset equal val dataset.take. What are we taking? We are taking the first 2 elements, which could be obtained by having this int val. So it's val test dataset now because I had to change this variable because we're doing something below, but initially it was val dataset equals dataset.skip. We were telling that we wanted to skip 60%, and then we were going to do val dataset equals val dataset.take. But again, we had to change this variable to val test dataset because we're doing something beneath. But it's still the same thing. It's doing the same thing. So we're taking the 60% or the 20% here. So we're targeting the 20% here, as you can see, with the int val ratio is 0.2. So after we print that out, we're going to get an output of 6.7. So that's because we're saying that after we do the validate, the val test dataset equals dataset.skip. After we skip these 60%, we want to target the first 2 elements inside of the last 40 elements, or the last 40%, or the last 4 elements, and that's going to give us the 6, 7, or just the val ratio. Notice that we targeted the last 2 elements that make up our val ratio set, which is 6, 7. Now, in order for us to get the last 2 elements, or our test ratio, 8, 9, this is what we need to do. We need to do a skip. Go down some. Now notice that we are creating a new variable to store our data in, the val test data set. Like I said, that's why we had to create the new variable, the val test data set, on line 692 and 693. This is just for example purposes so that we break it apart and use it to target the train ratio elements that we want. Also notice that we will be using half the new variable to skip the 2 elements that make up our val ratio set 6, 7. So this will be the new equation that we run to actually target our last 2 remaining elements that make up our test ratio, or 8, 9. So we have the test data set equals val test data set dot skip the integer or val ratio. So we're storing that inside of the test data set, and we're telling it we want to skip the first two elements, or the first two elements inside the last remaining four elements, which make up the val ratio. So we're skipping the val ratio, which is made up by the 6-7, and we're going to target the 8-9, which we have here, the output 8-9, which represents our test ratio. So we were successfully able to obtain our test ratio elements. Now, notice that we will return the last two elements that make up our test ratio set 8-9. Like I said, now we have successfully obtained all of the elements in our list of range of 10. We can always play around with the values to get a better feel for how things work. And that's basically what we did all morning. And it's just the breakdown right here, everything that's printed out. So you see here we have our initial. If you can follow my cursor, we have our initial range of 10 here. You can see here. And you can see here the 0 through 5 represents the 60% that we wanted. Then you can see here the 6, 7, 8, 9 represents the last four elements, or the last 40% that we targeted. And then you can see how we broke that up. So we have the 6, 7 here, which represented our validation data. And then we have the 8, 9 that represents our testing ratio data. And that's what we did all morning. And actually, we did a little something else. Like I said, I don't know if you guys recall from last night that I told you I was going to check and see if we can actually get that banknotes CSV over to our artificial intelligence course so we can follow along even further. And we were successfully able to do that. I'll show that to you now. So I did locate it, and I did download it, and I did import it into this file here, and that's this here. As you can see, I am utilizing the Rainbow CSV that actually highlights all of the different features and all of the different features and fields in different colors. So it's a lot easier to read and see what's what. But yeah, I did that this morning also. So tonight on our artificial intelligence course, I will be running that code. Let me see here. I will be running this code here for you guys after I walk through everything and make sure everything is working properly. So yeah. So that's that. Yep, I pretty much had a nice busy morning. We got everything done that we said we were going to get done. We got some coding done, and we did some learning. But as always, I'm going to keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.